Hello everybody and welcome back to another forecast. So today's video we're looking at tomorrow's threat because currently it's 10:37 p.m. So basically all we have going on right now is this day one outlook. I'm not gonna be looking at this because I didn't make a community post on this, but little 10% region for tornadoes, kind of all hazard threat for the Great Plains. There was an earlier setup for wind damage here in Virginia, but that's our main threat. Over here, I made a post about the Oklahoma region as well, but we're not gonna look into that just because I made that post on it and because that'll be outdated very soon. We're gonna be looking at is our day two outlook in our day two event. So basically, it's very similar to what we're seeing today or tonight as well. Significant hail, significant tornadoes, and possible wind damage associated with like the line segments going on. Mainly, that tornado and hail damage is our main threats, with our initial supercells performing hail, strong hail, and for those ones that are able to come surface base, we'll get possible strong tornadoes as well. The environment we have going on here is a negatively tilted trough moving to the United States. You can see it defined pretty well here. Here's our low pressure and our pretty good, closed low right there. As this moves on, this is right now. See our rat mile as well. See that eject off to the east. The name mile for a little bit more viewage, but you can see here, there's our trough, and this will eject off to the east. And later we'll likely be seeing yet another trough forming here as well. But that's our main system for now. Very strong flow associated with this. I believe this is somewhere around 60, 70 knots, 73 knots right there. Very strong flow, negatively tilted as well, and we have that defluence that we would like to see with these severe weather outbreaks. Not like outbreaks, but severe weather events, you want to see this defluence. You can kind of see it pretty well with these contour lines moving apart as they go. So that kind of leads to possible areas of rising motion that you want to see with these systems. I'll zoom in here as well and look at the Midwest sector. And there's our trough moving through. This is the end of tonight's system. Remember, tonight's system is going to be basically right at this point. This is 6Z, which is 1 a.m. Basically, a bunch of widespread storm coverage. I'll look at that real quick so you can understand what we'll be seeing into the next morning. Basically, just a bunch of little line segments and kind of conversion spans here. And these could be supercellular in nature. Likely a few discrete supercells forming here, maybe some embedded tornadoes as well. Into the morning hours, this will keep continuing, right? A lot of this motion will get pushed north. You can see our mean layer cape here, and you can see our storm motion because these kind of work together. Good instability, but the storm motion will go directly north. It means a lot of our convection will just get kind of pushed out of the way of our main system, right? We have our surface low getting warmer temperatures in this region. Any convection that forms, a lot of the time what we'll see is they'll move easterly, and that will end up kind of getting rid of moisture for the day, or at least for a portion of the day until it reforms. But in this case, all of our convection kind of just gets forced up to the north. Again, we're seeing it with the HRRR as well. You can see the HRRR, all that convection up to the north. That'll likely lead to kind of a rainfall risk on that half. Then what happens is we continue to have this nice open warm sector that will continue to go on even in the evening into the next morning. Here's our next morning hours, and you can see our risk area right here, 10% right here in the kind of this trifecta point, which we've seen quite a bit of this whole entire spring. Right here in this region, very good open warm sector. You can look at our dew points, very good 60s dew points across the entire region. Kind of a dry line cold front boundary here. See that pushing forward into the east. In the south, it doesn't seem to be as severe of setup going on. Maybe a little bit of a tail end, slightly more discrete mode in the south here. I get a good sector on it. You can kind of see what I'm looking at. Look at the HRRR as well. You can see maybe a few little updrafts here, maybe a few discrete elements there. Updraft helicity swaths, though, doesn't really show what you want to see. This essentially just shows where you can see some rotation in the atmosphere. The northern mode has a little bit more showing, but it's not as severe as the SVC showing either. I don't see a whole bunch to be said with this system, but I am going to look at it more. Plenty of cape for the entire region. Here's our mean layer cape, 1500 joules per kilogram plus. Definitely strengthens in the evening hours as well. So I'll take a RAP sounding from this area. See a very similar projection off this mile as well. Take a sounding right from the middle as well. Let's take one from down here near Arkansas. If I can get down there. Okay. From the Arkansas region. We'll take one right here in Arkansas as well. See what the environment looks like there. That's about at 0Z, 23Z. That's about storm hours. So here's our sounding from right in our trifecta point. And you can see not very good supercell characteristics. You have that rotation, but the jetting off of the winds isn't really there, right? It's very much speed share as well. You can see not much turning in the diagram over here by this QT. But you do have that rotation compared to the storm relative rotation here. Not very good jetting off the winds though. Here's our 3 to 6 kilometer shear, and it's just not really there at all. So what's likely going to be happening is we'll see quite a big line segment. But this shear in the lower levels like this, that means we'll have our little embedded possible tornadoes in the line. So that's how we could see that pressing. Also, pretty messy storm system just because of the way, again, as I said earlier, all of the mean winds, storm motion oftentimes seems to be very parallel to the line. That means any storms that form are going to run into and in front of this line just keeps getting stronger. So it could see more of a wind damage threat in that sense. Also, all those updrafts moving together, that's where you get the hail from. As we move on to the night, you can see this cape continues even on into the morning hours. Maybe even a more discrete mode in that morning hours as well. In the meantime, here's our Arkansas sounding. Again, much more supercellular. You can see that rotation, but more of a jetting off of winds. The more you want to see in that case. And cape is more widespread, so not super explosive cape in these lower levels, but 115 joules per kilogram down here, pretty good. I probably forgot to put that in the past one as well. Our Missouri sounding, plenty of 3 cape as well, and a very unstable environment, and pretty good moisture as well. It starts to mix a little bit, but these updrafts will be ingesting a good amount of moisture in the air. They could be more strong. The Arkansas one, though, you can see once you get past that moist layer, you have the EML in place, right? Here's our very dry region of air. That could hamper some of these updrafts as they try to form. Look at our sounding for the next day. You can see, once again, there's that shear, not a little stronger jetting off the winds, but not very supercellular in nature. Maybe a little bit of capping here as well, but once again, 3K pretty good. You like that? Definitely like that shear in the lower levels as well. So interesting to see how that play out. Might even be part of that. Any warnings in that region? Here's a pretty shallow cape. It's not very fat, right? You see your fat cape, you want to think of, here's our parcel. You get a lot more of that cape in that region, but unfortunately in this case we don't really have that. However, there's a good amount of cape. Not amazing for spring, but either way, if Storm's able to work with this, especially in that lower levels, we could get something coming out of it. One last thing I'll look at is going to be surface vorticity and 3 cape together. One of my favorite products to look at because it often shows where you'll see a line segment. In our case, there's not a bunch of surface vorticity, more so just a bunch of 3 cape, right? Our main method of forcing might just be a few little subtle convergence bands, or maybe a 100 millibar shortwave trough. But either way, we don't really see much of that in this case, right? Maybe a little semblance right here. You can kind of see, not really there very well, but there was a little bit of ink in the flow just then. Right here is where I'm seeing it. The little tiny ones, but they're kind of picking at straws in that case, right? Not too much of a very well defined shortwave going through here. It's just the fact that it's such a good open warm sector. So if these storms can ingest the correct amount of inflow, there does seem to be a good wind environment in the lower levels, and that's where we could see our tornadoes. But otherwise, I'm not seeing too much of the system. Besides that, it's more of a conditional threat. Just the fact there's so much cape. If you look at our STP significant tornado parameter, by the way, I was talking about community post, very strong sleep tornado parameter in Oklahoma tonight, so that's conditional as well. Going into the next day, you can see this parameter. It is composite, so I don't like to look at it amazingly, but or like religiously, but you can see pretty high in levels. You can kind of understand like what the wind environment will look like in that case. Supercell composite is also pretty high across the region. There's again, you can see it looks a lot better as well in this one sounding better color for that. There's shear and definitely more of that jetting off the winds. You could have a few supercells discrete. It just depends on what our forcing is going to be in that case. So could be subtle forcing, could be little conversions such as this. See, maybe convergence bands forming sometime around here. If you look at the surface, you can kind of see that as well. Winds are more out of the east in this case, more out of the south. So maybe a little convergence band in here. And then we look at our mean winds, understand what these storms are going to go to. Likely straight up. So you could have a few little discrete cells right here. That's likely where our threat is coming from. Is that just a little convergence band? I'll look at the HRRR, see if that's showing anything similar. Same. Yeah, more of a convergence band. So that seems to be where our main threat's going to come from. It's just kind of this little convergence band right here. HRRR isn't showing an amazing product for it, but you can kind of see that right here. Maybe a few embedded cells in there. And maybe in the behind the line as well. I think it's sounding from back there. Do it. Based on the HRRR. Yeah, there's our whole system. see if there's anything special going on there. But that's the main bits of this system. Much better cape behind that line, that is for sure. And here is a little strange, but it is there, even if it's going north. It's a strange photograph, but it is kind of supercellular in nature as well. Interesting to look at. That's our main progression with that event. The next day is currently a 15% risk. Nothing too significant there. We do have a day 4 outlook out for the Oklahoma region. I haven't looked too much at these as of now. They're a little bit far in the future because of how messy it's been, but the Wednesday one for the Indiana region is likely to be the exact same thing we're seeing right now. That overnight convection being able to form its way over. Or a widespread cape, though. Definitely more perpendicular to the line, so maybe more discrete elements in this case. I'll take a few soundings. Also, we have our dew points here. Pretty good, that whole region. 62 points, reaching all the way up here into Michigan as well. I'm gonna take a Michigan sounding as well. I like to get soundings a lot of the time, just kind of understand our wind environment. I'll take one last one from Tennessee. Here's our Ohio sounding, and it's kind of like mini supercells here. Not a bunch of inflow, but shear in the lower levels, a little bit of jetting off, not super strong. Maybe more high precipitation, but with plenty of 3 cape, 172 joules per kilogram, that's a lot. And much fatter cape than we saw in our earlier SQTs. So I do like this sounding for tornadoes for sure. This may be convectively induced because of the fact that you won't have this good of moisture going all the way up in the atmosphere. If we look at our wind environment, we can see something similar. I'm pretty sure our surface plot like this is pretty good. We don't really worry about this other dew point, but you can see this, a lot more widespread cape. It's higher up, so this could be more elevated storms. Maybe pose more of a hail risk, just how much cape there is going up in the atmosphere. And shear here, and not amazing for supercells, but there definitely is that shear, so you have to be careful with that. The embedded lines can form those tornadoes. Finally, we have a more southern option. Again, we're seeing probably more hail in that southern option. If I'm looking at that, you can see here's our hail growth zone in between these two temperatures. This is where we have most of our cape. So if hail is forming in our storms, right, you can kind of imagine this is our storm. We have our hail. Imagine that starts inflow going up the storm, and that will go up as high as it wants, and then when it starts falling back down, if we have a strong enough upflow or updraft going up, this hail actually will stay up like this until it gets heavy enough to fall as big hail. That's where we want to see our strong hail, or sorry, our strong cape right there in this vicinity right here. So that's probably more of a hail option in the south. I'll look real quick at our Oklahoma thing for Thursday as well. Looks to be small surface low forming in here. Get a little bit of semblance of rotation. Winds out of this way. Very kind of a weak rotation in there. Not very strong surface low. There's a bit of a open warm sector here. So especially with that cold front kind of pushing its way south at that point, might be able to see a little isolated convection right in this little region you want to see. I'll take one more sounding here as well. There's definitely moisture there. You can see this kind of dry line, cold front setup. You need to look at vorticity. Plenty of vorticity. So if there's 3K up here, it should definitely be stretched up. So we could see more of a PLCS for that as well. That's the Oklahoma one. Doesn't look too good. Might have better luck in the Arkansas region. Same. Well, there's the Arkansas region as well. So unique for that reason. Look at our cape. More capping in place here. So I'm a little curious on that threat. Maybe it's more for the overnight hours like this. Take one more sounding from that. This should probably be pretty bad sounding as well. You can see our wind environment, possibly mini supercells, but not much to be really gotten from it. Here's our last sounding. Better cape for hail for sure. Still a bit of a semblance of that EML in place. That's our elevated mixed layer. That's drier air aloft. 850 millibar will tell us what we want to see with that. Definitely see that through the NAM. We move to now. Through the Tuesday threat. Here's our EML drier air, definitely putting itself in place. And with our Thursday threat, definitely seems to be a bit of an kind of a messy dew point right there, but that whole idea definitely warmer above the surface as well, so that could lead to some capping issues as well. Otherwise, I don't think there's much else to be looked at. Look at the future product for 500 millibars. That can kind of show us a little bit about the future, but there's not really anything well defined after this. So nothing to be looking at too far in the future. That's our main threats. The severe weather week is kind of coming to a close now. that's our main threats for this. I don't think there's too much else. If there's anything else significant or really worth talking about, I will talk about it. But otherwise, that's about it for this video. And it's not looking to be very active later on in the week, but or not sorry, later on in the coming few days. But you never know what can happen. Sometimes quick genesis of a cyclone somewhere, you never really know. So with that, thank you for watching. I will see you in the next forecast. And if you're in the path of these storms, definitely be on the lookout. Stay safe, especially for tonight's threat. I'm a little scared of that one myself, especially wake up tomorrow and look at it. But yeah, that's all for this video. Thanks for watching, and I'll see you next time.